Today we're going to start looking at special segments within the triangle. Our first special segment is the median. The median is going to go from the vertex of your triangle down to the midpoint of the opposite side. So if I have the midpoint right here, the midpoint divides your segment into two congruent segments. So your median connects the vertex to the midpoint of that opposite side. Again, the midpoint is going to create two congruent segments. The altitude is going to be perpendicular to the opposite side. So the altitude is also going to go from the vertex and it's going to drop down perpendicular, and we know perpendicular lines are going to form right angles. The altitude can look a little different depending on what kind of triangle you have. Your altitude can be inside the triangle like we have here. If I had a smaller triangle with an obtuse angle, my altitude would be coming on the outside. If I have a triangle that's off center a little bit, my altitude will be coming down here. So the key is for the altitude, you're dropping straight down to create that perpendicular relationship. So a perpendicular bisector is going to combine the median and the altitude. Because it's perpendicular, when I drop that perpendicular bisector, it's going to form right angles. Because it's a bisector, it's going to bisect this opposite side into two congruent pieces. The median must go through the vertex. The altitude must go through the vertex. The perpendicular bisector can go through the vertex, but it doesn't have to. What it has to do is be perpendicular, and what it has to do is bisect that opposite side. Your angle bisector, we pay attention to this word angle, so it's going to deal with the angle. Since it's bisecting it, it's going to divide that angle into two congruent angles. So those are our four special segments that we're going to look at. Each of them give us properties that we can apply to solve in a given example. So in number one, we're given that AC, so our segment right here, our segment AC, is a median. The key here is median. Median means it's connecting to the midpoint. Since A is the midpoint, that means that this segment is congruent to this segment. Nothing else in my diagram has any bearing on the problem. The only thing I know to be true is that A is going to be the midpoint. And I know A is the midpoint because I have a median. We're not going to solve for X. We just want to set up an equation that would solve for X. So since A is the midpoint, I know these two segments are congruent. If I were to solve, I would set 6x plus 4 equal to 3x plus 28, using that median relationship of the midpoint. And number two, we are given that AC is the altitude. So again, we still have the same segment AC. This time, instead of it being a median, we're told that we have an altitude. We know that the altitude is dropping to create perpendicular lines, and perpendicular lines create right angles. So I don't know anything about segment AB and AD anymore like I did in number one. All I know is that this is going to be a right angle. So the equation I would set up here would be 5x plus 35 is equal to 90, representing that altitude, that perpendicular relationship. And our last one for our video, this one is giving us that segment AC. This time is an angle bisector. AC bisects angle BCD. So if I'm bisecting angle BCD, I follow that it's creating these two congruent angles right here. Anytime I have congruency to solve, I set equal to each other. So this one would be 2x plus 7 equals x plus 27. We have the exact same diagram 3 times, but based on the given information, will tell us what we know, and we can only write equations based on what we know. So be careful and you don't assume things by what you see on the diagram. Go off of what you're given, or what indicators you are provided with. All right, that's it for this video.